Graphing absolute value functions that involve a quadratic. So then now we have to go back to our quadratics unit and think about, well, how would I initially sketch this graph? So some key points that we need would be x and y intercepts, and obviously the vertex of the graph. Okay, so let's first start. We're going to graph, we're going to ignore the absolute value, and we're going to just sketch the graph of 2x squared plus 9x plus 4. So thinking back to our quadratics unit, first of all, since it's in general form, we're going to first talk about the y-intercept. And we know the y-intercept is the c value of our function, so I'm going to plot the y-intercept at 4. Now I'm going to find my x-intercepts. Well, to find the x-intercepts of this function, we need to factor this and solve the equation for when y is equal to 0. So when I factor this, I get a 2x, an x, plus 1, plus 4. This is 8. This is 1. That's going to add to 9. So my x-intercepts are going to occur at -1/2 and -4. So I'm going to plot these on my graph, -1/2 and a -4. The last point I want to plot is my vertex. So to find a vertex value, remember the quick way to do that algebraically is, remember your x value of your vertex is simply a -b divided by 2a. So I'm going to take my -b value, which would be a -9. I'm going to divide that by 2 times 2. When I divide those values, I get -2.25. I'm now going to substitute that in to my equation to find my y value. So my y value, when you substitute in, should end up to be a -6.125. Okay. All right, so now I'm going to plot this point. So my x value is -2.25, approximately there. -6.125 is approximately here. So there's my vertex of the graph. So again, we're getting a quadratic. We know my a value is 1, so we know this quadratic should be opening up. I'm going to lightly sketch this function the best that I can, going through all those key points. Okay, so this is my quadratic function. Now I want to take the absolute value of that quadratic. So again, thinking about what absolute value means, it means anything that has an output value in here of a negative. When I take the absolute value of that, that's going to change to a positive value. So all of these y values that are originally negative are going to turn positive. So my vertex that was at -2.25, comma -1.25 is now, when I take the absolute value of this, my vertex is going to be now -2.25 and a positive 6.125. So when this point down here is now going to be a positive value of y, not x. So your x's always stay the same. It's your y values that are changing. So this curve, it's almost like a reflection in this x-axis. So this curve is now going to curve up. So I'm going to darken that. And then my branches of my quadratic function that were originally positive y values are going to stay positive y values. So I'm also going to go and darken my branches. And that would be my absolute value. And then if you really need to, I'm going to take my eraser and erase the bottom portion of my graph. And that is how you graph a absolute value quadratic. Now, how do I write this quadratic or this function as a piecewise function? So again, I'm going to start with my squiggly brackets, right? And what are my two pieces? My two pieces are my branches? Well, my branches were produced by this original quadratic function, which is 2x squared plus 9x plus 4. Right? Thinking about our original function that we just drew. Right? This is our original. I only want the branches of that original function. So what can you tell me about the x values? Okay? Well, the x values are related to my x-intercepts. So my x value here needs to be all values that are smaller than or equal to -4. But also, I need all my x values to be greater than or equal to -1/2. All right, so how would I get this quadratic? Well, essentially, this shape of my graph is the exact same quadratic as this, except this shape is opening down instead of up. So how would I change this so it opens down? Well, it just means this entire function is going to be negative. And what can you say about the x values? We only want to graph this function in between -4 and a positive or a -1/2. So I'm going to say x has to be greater than -4, but less than -1/2. And that's how you would write the function as a piecewise function.